We have GW Cast joining us now here during Race Industry Week, and Jay Schofield, the head of sales and marketing. And today's topic for this particular session, Motorsport Foundry, how to make a NASCAR engine. And Jay, welcome. Thank you so much for being a part of Race Industry Week.
Hi, Brad. It's great to be here. I really appreciate you taking the time. I'm going to apologize a little bit in the first instance because I'm not going to tell you just how to make a NASCAR engine, but we're actually just going to talk about race car engines in general because, of course, there's lots of really exciting materials out there. And whether or not you're choosing to make engines from aluminium alloys or ferrous alloys, there's a huge amount of opportunities to get those incremental performance improvements that all the teams are seeking.
Yeah, I'm fascinated. I spent some time over the weekend and even just right before you came on here, just, once again, going over the website and everything that GW Cast has to offer and the technologies involved in what you guys do. Give us an overview of just what the company is and just really what you have to offer as far as precision and everything in motorsport.
Okay, well, going from the start, so we really are quite a historic company. So it's family owned. We're in third generation family ownership now, moving into fourth, and the company's actually been around for 77 years and started after the Second World War and as pattern makers. And as the business continued to develop, there was a natural transition there, moving from the pattern making industry into a foundry industry. And really, it very quickly emerged that there was an expertise in making these complex castings. It's what we describe ourselves by saying, if you want somebody to cast you a part, to make you a part, there's lots of foundries out there to do it. If you want somebody to engineer you a casting, then that's what we pride ourselves at being the best in the industry of doing. And over the years, we really forged a reputation within motorsport, all levels of motorsport, but certainly in the upper echelons of motorsport, as being the go-to foundry for all your casting and machining solutions, really. And we've worked with pretty much every level of motorsport for several years now, both in Europe and in North America as well. And as you quite rightly said, there is a huge amount of technology that goes into what is probably the oldest industry in the world. So if we, casting has been around for a long time, ever since it was the birth of the Industrial Revolution, but there has been huge advancements that have come on in the past few years, past 5, 10 years, even in the past 12 and 24 months throughout the period of COVID, that really allows us to push what we can do with castings to another level. And that's everything from the material development, the technologies, what you can achieve with new materials are quite literally breaking the mold in what you can achieve in castings. Through to some of the additive manufacture. So we rely a lot on printed sand technology, but then also in the back end as well when it comes to the metrology and the validation of the castings. So how that we can ensure the customer, or we can prove to the customer that you get an absolutely flawless product that's capable of delivering what you need.
It's pretty incredible. Well, let's talk about the casting processes. I'm just going to go on the assumption that a lot of people are familiar with what sand casting is, but the processes that you guys use and how it is advantageous for motorsports.
Well, look, it's easy, right? I mean, you just make a sandcastle and then you melt the metal and you pour it in the top and hey, you've got a V8 block. Yeah, I wish. Not quite like that. We are exclusively a sand casting foundry group, although we do actually use 3 different types of sand casting process. So we use gravity sand, we use a low pressure sand, and then we use rollover casting as well. And certainly for our aluminium motorsport foundry, that's where we focus a lot on using the rollover process, because that really helps getting the highest quality castings you can get. The material is melted. It's in a continuous melting process with sort of a 5-ton holding furnace. And when the metal is extracted from the casting, it's extracted from the middle of that melt. So all the impurities have sunk to the bottom and all the gas has risen to the top. So the metal that we're using is pulled right from the center of the melt. And that means that you're getting the highest quality metal available to use. That is then injected into the sand mold, and that is filled. And then when it is filled, it is actually rolled over upside down. And what that allows it to do is that as the casting solidifies and the thick areas begin, they solidify at a slightly slower rate than the thin areas, there is excess material that sits above that gravity is then forcing down to make sure that any areas of shrinkage that might be held within the casting at the point of solidification are compressed, so you get really, really good integrity, and you get a perfect casting throughout. So you're casting with the best possible material you can get in the best possible process you can get. So what's ultimately delivered is a flawless casting. Now, in that process, we tend to use two main aluminium alloys, 354, 357, all 300 series, but subtly tuned. And this is something that Grainger Worrall has spent a lot of time developing over the years. There are traditionally 6 big sand casting alloys. Well, within our portfolio, we have an excess of 50 different aluminium alloy derivatives, and they've all been developed for specific purposes. Now, up to this moment in time, casting has been generally used for cylinder heads, blocks, gearboxes, but it's a new world. And outside of motorsport, you look towards OEM, there is this mega castings, the giga castings like Tesla are using, where you're casting half a car, or all these thin wall body structures. And you're starting to see a lot of that technology proliferate over into motorsport as well, as people are seeing the advantages of how you can design strength into a form and then use casting to create the shape and get overall net strength improvements, but for reducing the weight. So the material development is something that we've spent a lot of time focusing on. And then also within the motorsport arena specifically, a lot of time and effort has gone into developing the use of the 200 series alloys, which people may or may not be familiar with. It started as an aerospace development, but in round terms, a 200 series casting alloy is about twice as capable as a 300 series casting alloy. So where you might target 220 yield, 300 UTS, 3-4% elongations from a 300 series, on a 200 series, you can get up to 550 UTS and up into double-digit elongations. So there's a huge amount of potential that we're seeing a lot of our sandcasting customers, motorsport customers, taking advantage of to really deliver those super high performance components.
That's incredible. Over 50 different alloys involved in something like that. A curious question, Jay. How much of that is, technology within the industry? How much of that is technology that GWCast comes up with? Or do customers ever come to you, with their own engineering and say, hey, we're interested in this? And, obviously at that point, if they're turning it over to you to produce something, basically you're keeping their secrets, but, still continuing to innovate on your own?
I mean, absolutely. Look, we recognize again that in motorsport, it's all about tenths. It's all about percentages that people are trying to achieve to get that competitive advantage. And that is the race team's IP. And we have to be super respectful and super protective of that. But there are only so many foundries in the world, in fact, pretty much us and maybe a couple of others, smaller, lesser foundries, that take part in the type of endeavors that we indulge in. And as a result, we do a lot of strategic developments with certainly the upper echelons that are looking for those percentage improvements. And you're looking at regulation changes that might be coming 2, 3, 4 years out. And these teams have got to start thinking about that now. And it really is superbly collaborative relationships in that they come to us as the technical specialists in our areas to understand what we can achieve. And is there anything that we want to go and develop? Is there anything that we think could bring a real advantage, but perhaps we haven't found the metaphorical vehicle so far to go away and develop that? And equally, we advise them, work with them very, very closely to help them understand how they can optimize their designs for the casting process. Because not only is it about trying to extract all of the performance that you can from the casting design and the material, but it's about optimizing that design so you're not carrying any excess weight. Now, I've always drawn a lot of synergies between motorsport and aerospace. Okay, may sound a bit weird, right? Motorsport, it's all about as fast as you can. How can we get the next result as quickly as we can? Aerospace, it'll take generations to get something in the sky. You might not ever see it yourself. But the common theme is zero risk. Because if you don't finish, you don't score. And if you don't score, you don't come back next season. Equally, you don't want a plane dropping out of the sky. So when we take that approach to delivering for our customers, we make sure that not only are we pushing the boundaries of what we can achieve from the materials, from the process, but it has to be done in a way that presents zero risk and it can be ultimately validated. So that when the cars hit the grid, you know that they're going to be finishing the grid. And if they don't finish the grid, well, it's for something other than component failure.
Well, you mentioned validating. How do you guys validate the parts that you produce?
It's a great question. And clearly, there is cast-to-cast variability, and we spend a lot of time making sure that all the parameters and all the processes are controlled so that the parts we produce are consistent in the batch. But nevertheless, once again, the upper echelons of motorsport, they have to make sure that every single part is validated. Zero risk, once again. How can you prove zero risk? So from a basic conformity perspective, all the materials that we used, we have separately cast test bars, every single melt. So every time we melt a batch load of metal, they go through chemical analysis and material property tests to make sure that they're hitting the required standard. When we produce cast parts and finished machine parts, all the usual suite of metrology tools are employed. So whether it be fixed head or moving head CMMs, contactless measurement system, but also what's been super important and a requirement that was driven into us by Formula One actually several years ago, was that they have 100% requirement for NDT, non-destructive testing, internal cast validation. And how we do that is we actually have 3 CT machines. The same type of CT machines that you might find in a hospital to look at your brain, we use to look at castings. They're subtly different. You don't make the castings lie on a bed and sit there for 40 minutes listening to music. Now, they'll sit on a platform that will spin around, but we can interrogate those without getting close to touching the casting. You can take up to 0.5 millimeter slices all the way through and then build a 3D picture, 3D CAD file of the casting. You can see if there's any areas of integrity, if the internal passages, water jackets, ports are dimensionally conforming. And then ultimately, you've got a record at the end of that to prove to the customer that the part that you're supplying meets standard. And should there be any issues whatsoever, we've got that record to then track back and understand where things may have gone wrong.
Wow, that's fascinating. It truly is. Jay, we have a couple of questions from the chat, if you don't mind. Jess is wondering. Oh, hang on, it just scrolled up here. Let me go back to that one. Jess says, I have a question about the sand used. I suppose it has to be very pure. What's the quality of the sand used for casting?
Good. In short answers, we actually use 7 different sand systems at Grainger Worrall, depending on the application. So we have zircon, silica, furan, phenol, and the others I can never remember. So great question, and thank you for embarrassing me. But basically, in the same way that we would take a material composition and tune that towards the application, we also do the same with the sand. So I'm sure you can appreciate that if you're a piece of sand and the cores are stuck together with the resin, and that might be an air set resin or it might be an oven cured resin, and you're sat there enjoying your day quite happily, and then all of a sudden somebody pours 750 degree molten aluminium or 1400-degree molten CGI or SGI in on top of you, it's not a very hospitable place to be. So those sand medias and those sand systems have to be tuned to make sure that they can withstand the rigors long enough so that the casting can solidify and give the shape that we need. Now, two of the key pieces of technology that we touched on, made reference to slightly earlier, was our sand printing technology. So we have 3 sand printing machines. In the same way that you can print plastic, so you can print metal, we print sand. And we actually use 2 sand systems within that. We use a furan-based system, which is for effectively creating bulk sand. And we use a phenol-based system. And that's actually a sand system that we developed ourselves at Grainger Worrall over a number of years. And it's a high hot strength. So what we're seeing on a number of certainly cylinder head applications is that the water jackets are getting so intricate, so fine and so delicate that you can't actually tool them. You can't make a pattern in a traditional way to make those. So we have to print the water jackets. And I'm sure you can appreciate, the amount of design freedom that offers for the customer. All of a sudden, all the constraints you had over traditional tooling is gone, and you can just say, I can make whatever shape I want. And that's really powerful in unlocking those percentages and those tenths once again. So the sand is very pure. It is very clean. Obviously, any imperfections that we have in there are going to have an adverse effect on the casting process. We do reclaim sort of 99.9% of our sand. So it is a circular economy, sustainable technology, because we don't want to be buying sand. We don't want to be, being unnecessarily harmful towards the environment. We can reclaim that. We can clean it of the resin, and then it can go back into the system. And that's for kind of the main sand systems that we use. But ultimately, all comes back to that key statement. We engineer a casting. And sand is as much part of that as the metal, as the method, as the casting design, as everything. Every process and parameter has to be understood and controlled in order to get the best quality part. I will just add one final thing, just on that point. My kids think I've got the best job in the world. They say, you've got a machine that prints sandcastles. Yes. Can I get a job doing what you're doing? Well, maybe try a bit harder. You see, I don't know. Nothing wrong with the foundry industry whatsoever, but I'm sure we can do better than printing sandcastles, right?
Yeah, I think that's fascinating technology. I really do. Would love to see it as well. Speaking of printing, this sort of goes to the next question. I know you had mentioned that, when you're doing the casting, you pull the metal from the center of the melt. The question is, does your casting process have the purity level that matches printed metals? As I understand, 3D metal is the purest metal available because there are 0 impurities. That said, the alloying base material may not be available. Do you see GW doing 3D metal printing?
Another good question. So DMLS, so metal printing is a technology that really came to the front commercially probably about 5, 6, 7 years ago. And a lot of people went really heavy into it really quick. And I think it's really struggled to find its position in the market. We do work with metal printed parts. It's tended to be around the precious metal inserts. So if somebody wants titanium, Inconel inserts, which we've done, so basically making smaller shapes and then overcasting them with the bigger shape. We've done some work with that. We've also done some work as well where we've supplied and supported customers with fully metal printed parts for pre-production builds. Tend to be more in the prototype era than the prototype arena than, say, the motorsport, because again, it comes back to that 0 risk attitude. And the technology is maturing at a quick level, but we very much see it as a complementary technology to casting at the moment rather than a competitive technology. The experiences we have had have been, on the whole, positive, but you need to think about it in a different way. There are constraints, even though on the face of it, you can just go print a shape. You do have to give consideration to that shape because it's not self-supporting. So if you've got ports if you've got water jackets, if you've got big cavities, you can't just print something into nothingness. It has to have a structure there to base itself on. And then quite often, once the form is actually created, you have to put it through a stress relieving process as well, because there are residual stresses that are held within the part when it is printed. So you normally have to heat treat it to normalize the metallic structure and also relieve some of the stresses that are in there. So it's definitely technology that we've been involved with. It's a technology that we've worked with a number of our partners on developing and providing solutions with. But I think for us, as it stands, as I say, it remains a complementary technology rather than a competitive technology to casting.
Okay. Deandra Leslie Pilecki, who is deeply involved in a lot of motorsports stuff. She said Jay mentioned CGI, compacted graphic iron. How much is CGI being used in motorsports engines these days relative to aluminum alloys?
Again, another great question. And CGI is being used in the upper echelons of US motorsport, certainly. I mean, greatest respect, guys, you love a V8, right? You still love a V8. It's not like us Europeans and we just 4 cylinders and turbocharge everything, or V6s. That's boring, right? No, you still love a V8. And CGI is a really, really capable material. So it sits between the traditional grey irons and, say, the upper material properties of an SG iron. But there's been a lot of studies done recently by a number of engineering houses that have actually managed to take aluminium alloy engine blocks and then convert them to CGI, which on paper shouldn't make sense, but actually the advanced material properties of CGI allow you to get thinner wall sections, get stronger crank journals, reduce down some of the thicknesses, so you can actually make an engine block from CGI for less weight than you would do an aluminium alloy. We're also seeing quite a big shift as well within the commercial vehicle market as well, because believe it or not, people want to lightweight commercial vehicle engines. I mean, these things weigh how many tons? But yet still, with the CO2 challenge that we have upon us, every kilo saved is absolutely valued, and by all these companies that are looking to develop the next generation engine. So to answer the question specifically, CGI is used. We do work with customers who specify CGI as their material for motorsport applications. Our ferrous concern, our ferrous foundry that we have at GW is a small niche foundry, but we do, again, lots of really high complexity casting jobs. So normally the traditional landscape for a ferrous foundry would be a big green sand automated line that just stamps them out and makes many thousands a year. The number of foundries that are around and about that will focus on making you, say, 5 or 10 or 15 or something to the highest standard with the validation to go with that are really, really limited. So whilst a small part of our business is a very important part of our business, and we do have a lot of experience in the CGI material and have worked very, very closely with Sintercast over the year to develop that capability.
Jay, this has truly been fascinating. I know we had some questions about maybe collaborative efforts and things like that, how much, you could maybe help with someone's design or whatever, but I know folks can get a hold of you guys through your page on the Epar Trade website and check out GW Cast. But a truly fascinating half hour just learning about this process. Thank you so much.
I appreciate it. I apologize for the background.
No,
I'll try and be in my
Jay.
office next time.
Stay on 1 second because it's I've had the privilege to go and visit Grainger, Brad, in the UK, and it's one, really, what I was saying when we started, it's one of those iconic British companies that play a tremendous part in racing, and they have been, it's a family-owned business, actually. They're on the 3rd or 4th generation, and the whole town pretty much there works at Grainger and Worrall. Am I right, Jay?
You're not wrong.
Yes, and it's a very, very, very good company. Thank you very much for being with us today, Jay, and wishing you the best for 2023.
Registering on Epar Trade is easy. To start, click on the Join for Free button on the homepage. First, search your company to see if it's already in our database. If you see your company on the list, click on it to select it. Then, choose Claim Company if you are one of the decision makers, an owner, marketing person, or main company contact. Or choose Join Company if you are an employee, and press Continue. If you couldn't find your company in our database, select Register a New Company. On the following page, fill out your name, email, phone number, job title, and choose a secure password. If you chose Register a New Company, you'll need to choose your business type. Select Supplier if you're looking to display products or services and connect with buyers. Choose Racing Business if you're looking to source new parts and connect with suppliers. Choose Race Team if you own or are a member of a professional race team. Then, enter your company name. Please provide a website, Facebook page, or LinkedIn if you have one, and choose to either claim or join the company. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Finally, click Register Now and your registration will be submitted for approval. An email will be sent to your inbox. Please confirm your email address and you will be approved shortly. Welcome to Epar Trade.